Hello and welcome. In this presentation, we will be looking at experimental probability, which will lead into relative frequency. We will be looking at two examples, and from that you should gain a much better understanding of experimental probability. So, consider this question here. Okay. Say I have a dice, or say I roll a die and roll it many times. It really doesn't matter how many times. The more times, the better. And I wish to calculate the relative frequency of rolling a 2. In other words, what I'm trying to do is determine what will be the probability that the next roll will be a 2. So, I'll actually use an electronic dice, an electronic die, and you can see here the first roll is a 4. I'll roll it again. The next roll is a 3. And what I'm doing is counting how many times each number appears on my die. I'll just pause the recording for a little while I go through and roll the dice many times. Okay, welcome back. And you can see that the tally I rolled the number 1 6 times, the number 2 4 times, the number 3 4 times, the number 4 3 times, the number 5 5 times, and the number 6 5 times. In other words, I rolled the dice, or the die I should say, 27 times. I'll just tuck that away, I don't really need that anymore. And to calculate the relative frequency of rolling a 2, I basically would use this formula here. The relative frequency equals the number of successful trials divided by the total number of trials. Now, very similar to the probability formula. So, what was I looking for? I was looking for rolling a 2. That is my successful trial. And how many times did I roll a 2? Well, 4. And how many trials did I have in total? How many times did I roll that die? I rolled that a total of 27 times. So I could say that my relative frequency of rolling a 2 equals 4 out of 27, or 4/27ths. That's the end of the first example. The next example is more of a worded question. Now, Rose, one of my favourite students from a couple of years ago, she was always late to school. Well, Rose was late to school on 10 of the last 15 days. And I wish to estimate the probability she will be late tomorrow. So, the relative frequency, because I'm dealing with experimental probability, is the number of successful trials divided by the total number of trials. Now, a successful trial in this situation would be Rose being late. And the total number of trials is, well, how many days have we looked at in this particular trial? So, the relative frequency, the number of times Rose has been late, divided by the total number of times she has attended school. And there you go, the probability that Rose will be late tomorrow, well, that equals 10, because she has been late 10 of the last 15 days. So 10 out of 15, which equals 2/3. Well, there you go. There are two examples that I have gone through looking at relative frequency. The first one, where you are given basically two values, and you operate very much in the same mode as calculating the probability, and the previous one, where you'll work through a tally table to work out a total, and then you need to divide that, the total of a successful trial, I should say, and you need to divide that by the total number of trials. So I hope this presentation has been of assistance to you, and until next time, good maths.